Isn't that crazy how I jump around? Okay, so number 5, we're going to do tomorrow in Desmos because I want to show you how to do those domain restrictions on the graphs and do the piecewise function. Not as pleasant in your graphing calculator, so you would have to know how to do that without the graphing calculator actually, but Desmos will be a nice way to discover it. But we are going to solve number 6. Okay, so on this first one, of course, I'm solving for x, so I'd like to start getting rid of stuff, and I notice the natural logs out in front. So in order to get rid of that, I can do the inverse operation, which is power up, and when I chose a base of e because the natural log has a base of e, and so when this base that's on this and this base on the exponential match, we just talked about the fact that those cancel each other out. So now I have x squared equals e to the 10th, definitely not going to calculate that. And then I'm still trying to get x by itself, so of course I square root, and I have to remember that when I put in the square root symbol, plus or minus goes with it, so I get x equals plus or minus the square root of e to the 10th. And if you remember, whenever you have anything inside that looks like a variable, which e does, and you have it powered to any power, that you can start pulling out 2 at a time because I'm doing square root, and so I'm pulling out in pairs, and so it's going to be x equals plus or minus, and I have 5 pairs, so it'll be e to the 5th. Kind of a shortcut is to do the power on the inside divided by the index on the outside, and that gives you your value, and if there's a remainder, they would go back on the inside, but there isn't a remainder. Okay, the next one, of course, on the left-hand side, when I raise power to a power, I multiply those exponents, so this becomes e to the 12x. And when I have like bases, I can disregard the base, because obviously if the left and right sides are equal, then those exponents must be the same value, or you won't get an equality. And then solving for x, I bet you thought it was 2, didn't you? Ooh, gotcha. Remember, you're doing 5 divided by 10, which is a half. Okay, and then this last one, this is a crazy problem. I wouldn't expect you to probably get to this on your own, so I'm going to give you some little hints along the way and see if you can see a mathematical pattern. First of all, there are 3 terms, and I do have some exponents. And if I notice, since there's 3 terms, I'm thinking, ooh, it's trinomial. I wonder if I could factor this thing. Now, it's a quadratic wannabe in that I see this exponent in the front, and this one could be half of that, or is half of that. I'm not sure about that plus 2, though. What the heck's going on there? So this is what I attempt, because I say, oh, you know what? I can split that stuff, because it would have come from this. And if you think about it for a second, these 2 values right here, I would, since they have the same base, I would add the exponents, which is what I had up here, 2x plus 2. So then I note that this power is half of that, which is what makes it a quadratic wannabe. So I'm going to place this out front, and I'm going to start to factor this. So since I want this middle term to have a 3 to the 2x, I'm going to do 3 to the 2x and 3 to the 2x. Now, I want you to think what happens when you multiply these 2 back together. It does give you this first term. Okay, now, this last term, ooh, I could rewrite that. Since I noticed this one has a 3 squared, I go, oh yeah, there's a couple of 3 squareds in this one. I could rewrite it as 3 squared times 3 squared, which means I could put both of these at the end. And now this center is supposed to be negative, and this is supposed to be positive, so I'll need a negative negative to make that work. Negative negative. And then if you FOIL this back, it actually works. And of course I'll set the parentheses equal to 0. They're both the same, so I only need to do 1. And if the bases are the same, the exponents must be equal. So when I finish solving, I get